guys, Paul, Inventor 3 here. Let's see, happy Merry Christmas. Almost New Year's. Almost Christmas. Alright. In this video I'm going to be revealing more than I've ever revealed before. I'm going to show you the schematic as much as I can reveal to you of the 1,500 LEDs I had lit. I can't reveal everything, guys. You got to watch my video on why I keep secret, and I'll put a link to that in the video description below. Okay, I'm going to talk about my negative to negative setup in my 710 LEDs to 1,000 LEDs. I'm going to talk real quickly about my free energy from air circuit. I always point back there. It usually is always hanging back there, or I had it outside my lab. I got the antenna going from my lab to my house roof. I've been working on that for 13 years. We're going to talk a little bit about that real quick. I'm going to tell you and share with you some information about radio. Okay, and then last but not least, I'll show you a simple setup that I have and the schematics of that, of how I'm getting over 300 volts from my system right now with only 20 volts output. Okay, so let's do that. Alright guys, here we go. Here's my frequency generator. Okay, I've got, now this is for my 1,500 LED setup, my new record. I have 12 volts applied. Per the manufacturer, this can only put out 100 milliamps. Now, I do hear an internal clicking and a sudden brightness in LEDs when I go from like 6 volts to 7 volts. So I almost feel like, and I should ask them, but I feel like this is designed maybe going from 6 to 7 volts. Maybe it's putting out or 25 milliamps, and then you know, from like 10 to 11 or 12, then it puts out 50 milliamps, you know what I'm saying, and eventually get up to 20, then it's putting out 100 milliamps. But anyhow, let's keep going. 100 milliamps, 12 volts, 1.2 watts. Here's my positive. 40 megahertz wavelength wire. Okay, here's everything here. It's 0.032 diameter wire. I forget what gauge that is. 22, 23, 20, I forget. The length is 24 feet 7 inches. That equals 40 megahertz. My core diameter, PVC piping, 2 and 3 and 7/8. I got like approximately 39.5 turns. Okay, and I've showed you this, guys, a million times. There's my frequency generator. There's my primary coil, the one on the right. This one's not used right now. I've showed you that many times, many videos. This goes to my secret sauce. This is the wireless part of my system. I'm not going to give you details about that. We have to worry about the Inventor Secrecy Act being slapped on us, guys. I'm trying to protect you and us, guys. You don't want to put this stuff out here before I've got it fully developed. And then all large corporations come swooping in, and they got an army of geniuses in a room overnight, and they'll have everything patented overnight. Anyhow, long story. Watch my video why I keep secret. Alright, there's rows and rows of 10 LEDs. 2 diodes. Now I've got my earth ground here. It's an earth ground, rod in the ground, not the third prong on your, you know, on your, from your wall. It's not the water pipe from your house. It's got many devices hooked to it. Just I got about 12 inches in the ground, probably 5/16 diameter or something. Now, as I have about 100, 200, 300 LEDs, this earth ground is needed and necessary. As I get up to 1,000, 1,500, this earth ground becomes unnecessary. Now, I will say that if you want to turn the power of this frequency generator off, look at these LEDs at night and see them still lit, very dimly, but still lit, then you have to put that earth ground back on. Okay, because the energy is coming from the earth. A lot of it is. Anyhow, let me move on. Okay, next thing I want to talk about is these. This was my LED setup with 710 to 1,000 LEDs. I basically added 290 through Affirmenco plugs. Anyhow, I had I added some more on here recently through experiments, but I had 20, 40, 60, 80 LEDs. They're all in series. Okay, it's 160 volts at least. Anyhow, they're in parallel with another 160, in parallel with another 160. Now the negative end of all those come together to one point. Now down here, I had like another 468 LEDs. Now these are jumbo 10 millimeter. These are 3 millimeter. Now maybe if they were all the same size, it would have been even. I don't know. But since this is what I had at the time, now this is 156 in series, and another 156, and another 156. That's was at 312 volts or something. Anyhow, I hope I just said that right. I'm just trying to go quick here. The negative end of all these LEDs. Now this is what interests me. Over the last 2 years, nobody's really mentioned this, and I've mentioned this at least 3 videos. The negative of all these LEDs down here, 468, are connected to the negative end of these 240 up here. Now this became the most active spot in my circuit. It gave off such a huge field, this electromagnetic field. Much energy you could suck from that. But anyhow, now the thing is, alright, here I'm going to show you something. I don't have the schematic drawn up, but I would take the positive end of each, the first 10 of these LEDs, and these LEDs, and these LEDs, connect them together and bring them over to here. Now you see only 2. That's because one kind of goes over here and branches off to one. This branches off to another one. So there's actually 3 strings are all connected. The positive end of the first 10 LEDs in the string connect over this side of this bridge rectifier. And actually this could have just been 2 diodes. I don't even need this end. Nothing is connected here. The negative end of this I connected. There's some alligator clips missing, but these I connected to the negative end over here of each 10 LEDs in each string. And then here, of course, I connected to earth ground. Okay, so the only way, and this is what nobody's ever mentioned, is, hey Paul, wow, how's that possible? Or it makes me wonder, maybe I'm missing something. You know, hey Paul, this is just, you know, common knowledge or something. I don't know, but you know, they have 400. This is the LEDs, light emitting diodes, one-way valves, the negative to the negative. The only way these could be lit up is through the ground, earth ground. Maybe I'm wrong about this. Maybe I'm wrong. I don't know. But that's really interesting. Okay, so And it only works when you get the right amount balanced with each other. And when both sides do balance with each other, these 240 do not dim out at all. See, I really believe I've got, from all my experiments, I've got a positive and negative end. And you could keep them balanced, or you could tip the scale, one up, one higher, one lower. That's why I'll get two resonant frequencies all the time. Now I could way balance that scale, that one way up, this side way down. Now all of a sudden I'll only get one resonant frequency, this one. It'll have more energy. This one will be gone off the charts now. And I'll get a lot of energy here. But there's different ways to tackle this. Now here I kind of believe I've got things even. And I was able to double, more than double the LEDs without increasing anything. Anyhow, I'm going to keep moving on here. Okay, next thing I'm going to talk about, well, real quick, with my 1,500 LEDs, there might still be a way that I could hook up another 1,500 LEDs to that without even dimming these out. It really depends. So now, I just wanted to say that I'm going to go on to talk about my free energy from air circuit real quick. Just make a point about that. Geez, I was working on that for 13 years, guys, on YouTube here. I've had many series on it. Eventually, though, I'm, you know, at the highest spot, I'm on like 22 feet high, like 60 feet long, and I get over 127 volts. Now, there's a coil that I have out there. It's very special, and I've showed you this in videos, and yeah, anyhow, I'll make this quick. But there's a coil I always add. Many people over the years have asked, how do you connect it? But no one has ever said, again, you know, wow, Paul, how's that happening? I don't understand. How can you have a transformer with only one coil? I have one coil going through a center transformer, so I guess that would be a 1 per something ratio. And that one thing going through the center of the coils is the ground itself, gained over 40 volts. And the other thing I want to point out is, I think that's a discovery. I think the way I'm doing my system right now, not free energy from air, my project you've seen here, I think there's 2 or 3 discoveries in there. The negative thing is very important. How I'm collecting energy is extremely important. Anyhow, with that coil out there, my very last episode of Free Energy from Air, and I'll put the video link in that description in the description of this video below. What was I saying? Oh, okay. I was showing, it was kind of a boring video, but I spent a couple weeks researching into all the math and energy and joules and watts and all that stuff. And, you know, what I basically showed is that the more voltage I added to a capacitor, faster and higher you were able to charge it. It didn't really matter about the current. I only had microamps. And that's a very important point, because Don Smith also went from a 12-volt battery to 8,000 volts using a transformer or a module, a laser module from an old Xerox machine with many fine windings and dimensions on it. And I'm going to show you those schematics in that real soon here. And he mentions, oh, I only had microamps at that time, like 30 microamps. And that's, you know, at one point in my research too, I had learned it's about the voltage, guys. It's not about how much current you can get. Don't worry about the current. Get the voltage, okay? When you take a capacitor and you short it out, discharge it, or run across a spark gap or some LEDs, there's your current. You get your current back in the end, and that's what I've said for years. All right, let's move on to the next point. Okay, so now I'm going to talk real quick about radio. Okay, and I have a video in my video series about this project. There's a video called Wireless Power Transfer, 4 Important Points. And I'm just going to emphasize on a little bit there about radio here. And I'll put the link to that video in the description below, which is also a very important 4 important points. Okay, about 6, maybe 7 years ago, I looked into radio. I asked, well, way before that, but I asked a question 6, 7 years ago about how does a radio tower know how many listeners they have? And you know, I often envision like this needleless graph. Whoa, whoa. You know, oh, we got more listeners. Whoa, whoa, look at all the people listening now. No, it's not like that. It's not like an electric company. If you think about in the hot summertime, everybody turns their air conditioners on at once. And all of a sudden the guy at the electric, you know, we're having brownouts, and the guy at the electric company is like, hey buddy, next door, yeah, you know, send us your backup power from your backup power plant. Yeah, now our air conditioners, everything's back up. No, radio is not like that, okay? It doesn't matter if you have 100 listeners or 1 billion listeners. Now, I'm going to show you a couple things here. Now, geez, hang on. Now, right, that's what I was going to say. About 6, 7 years ago, I investigated into it. Then I said, how does a radio station know how many listeners they have? And actually, the only way they know is through surveys and this other device they call a personal pocket something or other. People would clip on them, or you know, and it would record actually what they listen to in the morning, on their way to work, at work, on their way home at night, and they would get that information back to them. That's the only way they know. It's not like the radio tower bogs out like the electric, like the power stations. No. Now let me show you this real quick. Okay, I want you guys to think about this, okay? Stuff in the upper left-hand corner here, just ignore that red stuff. That's old notes. Just stuff to myself. This here is the 4 important points for my one video. Okay? There's something I just had to draw up. There's a little radio tower. And there's some people down here. Something you gotta think about. Now think about the 1800s. We all got crystal radio sets. There's no, you don't plug it in the wall. You got no batteries. Okay, and this is like the nearest person, like maybe a mile away, and is the nearest person maybe 50 miles away. And yeah, this is the amount of energy between that line that we're collecting. It's one thing I want you to think about, and that's all I can say about that. 2, think about this. It doesn't matter if you have 100 crystal radios down there. Now, they don't have to be using their energy for sound. It can be used for light, or that energy can be transformed into electron current energy. Now imagine if you had 1 billion listeners down here, or LEDs, or whatever you want to call them. they could all be collected together, and I guarantee you that amount of energy will be greater than the amount of energy they're putting out in this tower. A lot of wasted energy. Anyhow, now let me continue. Now Don Smith too had mentioned in one of his videos that I saw just last year about radio, and it gave me chills. And I keep getting chills over and over again because he keeps like mentioning the same things that I've come to the conclusions of over these years. Now these are just some quick notes that I'm going to show you that I've taken from one of Don Smith's videos. And I actually have the link to it not below this video, but you have to go back to my first video in this video series, in this project series, part 1. And look under there, and there's the video link to the first video. I forget if it's like 2, 3, 4 hours or something, but I've watched it 3 or 4 times over, taking detailed notes each time. Here's just some of it. You guys gotta pause. I'll zoom in a little bit. Pause where you want. There's this laser module. Many fine windings. Kicker coil. You're gonna have to pause the video as you need it, guys. There's only 3 pages of this. I got stuck on the first stage, between the first and second stage. I don't know if I've discovered what he's been hiding. I don't know. Now you see this coil there? That's an extension. That's that one there. Oh, this. Oh, wait. No, that's okay. Keep going. This will save you the hassle of having to watch hours and hours of videos, too. How he transforms it back down in the end to around 100 volts and 60 hertz. Now this coil here goes on to page number 3. Now guys, I remember him watching in the videos that I've seen. He talks about he's eliminated the spark gap. He's eliminated the coil inside of a coil. So I don't know. You know, I've also read he's had over 40 something versions of his project. I'll be right back. Alright guys, here is some more very important information and notes that I've taken. Okay, about his components, and this gets me all the time, and I agree 100%. You can see about, he mentions about components, you know, just like a resistor is a better capacitor and inductor than it is a resistor. And there's some other notes here if you want to pause or look at it. So this is a very, very simple setup I'm going to show you in just a minute here. But, you know, one thing that's making my experiments difficult is exactly what I just mentioned to you a second ago. Now, let's take, for example, an LED. Let's just pause this camera somewhere. just an LED alone, guys, is one, it's a light emitting diode. It's a one-way valve for current. It's a diode. Two, it's also a resistor. Depending on how much, in my opinion, it varies. Depending on how much voltage in that is applied. But anyhow. Three, it's also a spark gap. Now you got to remember, spark gap, just like my Tesla coil, my Tesla hairpin circuit, that spark gap also determines your frequency, controls it. You could have one big spark gap on my Tesla coil or many small ones, and believe me, the spark gap controls the frequency. Four, an LED is also a capacitor. You have two electrodes in there, in that junction there's an anode and a cathode, and it's got to build up a certain amount of voltage to jump across that air dielectric. Okay, real quick, guys, I'm running out of recording video. Last but not least, I want to show you this simple little circuit that I have set up here. You can see I've got 232 volts across there right now. And that's with 12 volts applied, 2.75 megahertz. At 20 volts applied, the most this can put out, I can get over 350 volts. There's my primary coil. Whoops, there it is. It's my old one next to it. My old one next to it that's not hooked up. Hang on. Okay, now I'm also running out of power. Here's the schematic I just showed you. Now checking voltage, actually I don't show it, but across the capacitor here, my voltmeter. The voltage across these LEDs will only be about 25 volts. Maybe more right now. The voltage across that capacitor, I can get up to over 350 volts. Food for thought, guys. There's 20 volts. And I get 340 volts across the capacitor. Now yes, I could light at least two of those bulbs in series with each other, but across that capacitor, or in parallel with the capacitor. Well, guys, next stage I think is I have to start boosting the voltage. Find a way to do that. Alright, guys, there they are, and I connected them off of the capacitor that I had set up over there. Now it shows 24.6 volts, and that's what you have across each 10 LEDs here. I added another 150 LEDs going off there in the background onto my Tesla coil. So it's another 160. I'm sure these are extremely bright over here. I'm sure I could replace this whole string with another 1,500 LEDs. Okay guys, just one more quick clip here. The same setup that I just showed you guys. Instead of my 1,500 LEDs coming off of the capacitor, I disconnected them and I just have this, what is it, 12 watt or 12 volt, 70 watt LED panel. This might be the brightest I've had it lit so far. But anyhow, the important point here is the more of a load you put across this capacitor, the brighter these LEDs and more energy will get. These LEDs are in series with this capacitor. I've already showed you guys the schematics. Alright, now I've just moved around to this side of the table here where you could see how blinding bright these LEDs are, man. They're extremely bright. Now again, we're still at only 12 volts. I'd be afraid to turn it up more from right now to blow out those LEDs. Go to any online LED calculator. Tell it you've got 12 volts and you're lighting 20 LEDs in series and see what it says. Those are blinding bright. I don't have my meter on. It's only about 9 point something volts. Otherwise that panel would be a lot brighter. So yeah, that's just another very important point I wanted to add with this setup. Kind of want to balance those a little bit. Now when I connect my 1,500 LEDs across there and I've got this chain of 10 LEDs going across my table onto my Tesla coil, well, those 160 LEDs there would not be lit up nearly as bright if I did not have the 1,500 LEDs across the capacitor. So the load across that capacitor matters greatly. One last quick note, guys. If you kind of figure it out from my notes, or whether you don't, you try to replicate what I got going on, please give me some credit. Please. Thank you.